All right, today we're diving into something pretty wild. We're talking about artificial intelligence stepping into one of the oldest, most purely human fields you can think of, mathematics. And listen, this is way more than just about faster calculations. We're talking about a fundamental shift in how discoveries are made.
So let's just jump right in. Get this, an AI just solved a math problem that had brilliant human minds totally stumped for months. I mean, this isn't science fiction anymore, you know? This is a real deal headline, and it's signaling a brand new era for a field that's been around for thousands of years.
Okay, so what's the big deal here? What does a breakthrough like this really mean? Well, it's not just about solving one tricky problem. It's about a whole new kind of potential, a new partnership.
And here's the crucial part. The AI isn't just a super-powered calculator, out-muscling mathematicians with brute force. No, it's starting to act like a creative partner. It's suggesting new paths, helping navigate these incredibly complex problems. It's a whole new kind of collaboration that's shaking up a field that we've always seen as the pinnacle of pure human intellect.
Now, to really get why this is such a game changer, we need a little context. We have to talk about a problem that's been quietly growing in mathematics for decades, and that's the just insane complexity of modern proofs.
Okay, check out this timeline. For centuries, mathematical proofs were all about elegant logic. The ancient Greeks, pen and paper, super pure. Then, bam, the 1950s hit and computers get in on the action, at first just helping to check work. By the 70s, they're becoming more like interactive partners. And that, of course, brings us right here to today, where we are on the verge of true AI collaboration.
And the scale here is just mind-boggling. Let's take the famous four-color theorem. To prove it, a computer had to grind through and check over 600, that's 600, different cases. I mean, there's just no way a human could do that reliably. It's a perfect example of this complexity wall that mathematicians were running into. And it's not even just about counting cases. Some of these modern proofs are thousands of pages long. Thousands! Imagine trying to proofread that. It's a massive job, and even the sharpest minds can miss a tiny, subtle error. So yeah, the need for better tools to manage all this complexity, it became totally undeniable. And this is where AI enters the picture. But not as a replacement, not at all. Think of it more like a powerful new partner, a co-pilot for the journey of discovery. So, what is the AI actually doing? It's not magic. In simple terms, it's using machine learning to dig through mountains of existing math, right? It's looking for patterns, things a human might just not see. And then it uses that knowledge to suggest new ways to attack a problem, or to double-check these ridiculously complex arguments. Let's break that down even more. So step one, the AI basically reads a giant library of existing proofs and solutions. Then step two, it tries to apply those same patterns to a brand new problem that nobody solved yet. It learns through trial and error, kind of like we do. And finally, it takes its best ideas and serves them up to a human mathematician, saying, hey, what do you think of these steps? And this is really the key. It's not a competition. It's all about playing to your strengths. It's a team up. You've got the human with the creative spark, the intuition, the big picture thinking, and the final say, which is crucial. And then you have the AI with its tireless number crunching, its incredible ability to spot patterns, and its knack for catching errors. They really are the perfect pair. So what does all this add up to? Well, you get the heart of this whole transformation, a new kind of augmented reality for mathematicians. The goal here, the big vision, isn't to get rid of human mathematicians. No way. It's to create the augmented mathematician. Just think about that for a second. It's a researcher with a tool that can instantly check their work, point out connections they might have missed, and just handle all the tedious, grinding calculations. That frees up their brain to do what humans do best, make those big, creative leaps. And hey, this isn't just some sci-fi dream. We've got leading lights in the math world, guys like Andrew Granville and Jordy Williamson, who are already super optimistic about this. They're seeing considerable untapped potential in this exact relationship between human insight and machine learning. Ultimately, the hope is that AI grows into more than just a tool. The goal is for it to become a trustworthy co-author. I love that phrase. A partner you can actually rely on to contribute real, meaningful ideas to the creative process of discovery. Okay, so let's look forward. Where is all of this headed? What does the next era of math actually look like? I mean, the potential here is just enormous.
The pace of discovery could accelerate like crazy. We could see AI helping us uncover completely new theories we hadn't even dreamed of. It could also build bridges between different fields of research and, this is a big one, hopefully make these powerful tools available to way more people.
But of course, a future this powerful doesn't just show up perfectly packaged. It's not that easy. It brings up some really big, important questions that the entire math community is going to have to tackle.
So let's talk about the fine print. First up, reliability. How do we know for sure that an AI-generated proof is 100% solid? That's a huge one. Then there's the issue of bias. Could the AI models have hidden biases from the data they were trained on? Absolutely. We have to address that. And finally, access. Who gets to use these incredibly powerful tools? We need to make sure they're shared equitably. How we answer these questions is going to shape everything.
Which leaves us with a really fascinating question, one that's going to define the next chapter of human knowledge. The next time a huge, world-changing mathematical discovery is announced, who's going to get the credit? A human? A machine? Or, and this seems more and more likely, will it be both?